In today's notes, we are going to discuss point-slope form. Point-slope form is just another form to write in a linear equation. You need to have a point, and you need to have the slope to write it. Now, you should be familiar with slope-intercept form, where the two objects for slope-intercept is the slope and the y-intercept. So m is still your slope, and then your b value will be the y-intercept. Now, we're going to convert to slope-intercept form from point-slope just by easy distribution. So in example 1, it says write an equation of a line in slope-intercept form that passes through 1, 3 and negative 2, 9, and then to graph it. Now, our end goal, what we want to do is get it in slope-intercept form. But right now, we need a slope and y-intercept. Now, the slope is really easy to find. The y-intercept we can't do, at least not yet. So, we need to find the slope. Now, we have two ordered pairs. So, we are going to do the y2 minus y1 over x2 minus x1. And we're just going to plug in after we label the ordered pairs. So our y2 is going to be 9. Our y1 is going to be 3. So I got that from 9 minus 3 right there. And then I'm going to do my x2 in this case is negative 2 minus 1. Now 9 minus 3 is 6 over negative 3. So we want to simplify that to negative 2. So that is my m. I finally got my slope. Now this part is going to be the tricky part, the y-intercept. The y-intercept, you have to be careful because that's when x equals 0, and we don't have that yet. So what we're going to do, we're going to use the point-slope form. So the point-slope form is now y minus y1 equals m times x minus x1. So the nice thing is we already have these pieces. Our m is what we just found. And then we already have our x1. And we already have our y1. We already have those pieces labeled. So my m is going to be negative 2. And then my x1, y1 was from the original problem, 1, 3. Now technically you could use negative 2, 9. You'll get the same answer. Your work will just look slightly different. So now we want to plug in that information. The y stays minus our y1. I'm going to put it in parentheses. Our m, which we just found to be negative 2. Parentheses, x minus our x1, which is 1. And then from here, we're just going to simplify. Y minus 3 is just written as y minus 3 equals negative 2, parentheses. Now x minus 1 is just x minus 1. So right here, This is point slope form. Remember that the equation is going to be slope-intercept form. So we need to do some algebra for that. So we're going to do the y minus 3 equals negative 2 parentheses x minus 1. And we need to get y by itself. We need to solve for y. So we're going to distribute negative 2 times x because we want to get the parentheses alone. Negative 2 times negative 1 gets us a positive 1. And now we're one step closer to getting y by itself. So we're going to add 3 on both sides. So now we have an equation that is y equals negative 2x plus 4, which is in slope-intercept form. We have our m and we have our b value. Now just review on how to graph that. So this is not brand new information. Try to make your graph as straight as possible and your tallies as straight as possible. Now you want to make sure that you graph at the y-intercept, which is a positive 4. Now the slope is negative 2, so that's really negative 2 down, 1, 2, and over 1. Down 2, right 1. And you can keep following that pattern. Now you want to extend your line all the way through the graph and put arrows on the end. Now, if you wanted to go backwards, you would just go up 2, and then right 1, and then you can keep going with that pattern over and over again. Now, what I would like you to do is try it. I would like you to hit pause, and then you will be able to check your work as soon as you hit play again. So please hit pause and do the try it. All right, so hopefully you've already hit pause and you've tried it. The first thing you want to do, our goal is to get slope-intercept form. So we want y equals mx plus b. But we only have 2 ordered pairs and one of them is not the y-intercept. So if it's not the y-intercept, you have to start with point slope, which is y minus y1 equals m times the quantity x minus x1. So we have to start there. Now we are not given the slope, so you have to find the slope. So we're going to do x1, y1, x2, y2. So then it's negative 5 minus 1, and then negative 4 minus 4. So negative 5 minus 1 is negative 6 over negative 8. We can simplify that. Negative over negative is positive, so 6 over 8. And we can divide 2 out evenly on the top and the bottom. So then we get 3 over 4. So that is going to be our m. That's our slope. Now we already have an ordered pair labeled x1, y1. So now we have our slope, which is 3 over 4. And we have our ordered pair, which is x1, y1. So now we're just going to plug in and then simplify. So y minus our y1, which is 1, equals our m, which is 3 over 4, x minus our x1, which is 4. Now remember, this is called point slope. And we want it to be in slope-intercept form. So what we do is just simplify by distributing and solving for y, because slope-intercept form has y equals mx plus b. So then we have y minus 1 equals 3/4 x, because we're just distributing. And then 3/4 times negative 4 gets you negative 3. What you want to do is just put that in the calculator. 3 divided by 4 times negative 4. So that's how I got negative 3. And then I just add 1 on both sides to get rid of that minus 1. And then we have y equals 3 over 4x minus 2. So make your graph as even as possible with the tallies. And then we're going to graph from the y-intercept, which is negative 2. And then our slope is telling us to go up 3, right 4. So up 3, 1, 2, 3, right 4, 1, 2, 3, 4. You can keep going with that pattern. We can go up 3 more, right 4 more. Now if you want to go backwards, you would just go down 3, left 4. And then draw your straight line all the way through the graph, as straight as possible. And you have to have arrows on the end. Now, one thing that I did not mention in the previous problem, notice that we have 4, 1. Notice on my graph, 4, 1 is a point. I have negative 4, 5. I have negative 4, 5. So that is a way that you can check your work to make sure that your line has those two ordered pairs. So since I do, we're good to go. You can even notice that in this above problem, 1, 3 is located right here. And then if I would have kept going, negative 2, 9 would be on that line too. I just didn't go one more location. All right, example 2. Example 2 is slightly easier because we give you the slope. So if we have the slope and an ordered pair, we can just do y minus y1 equals m times the quantity x minus x1. Remember, that is point slope form. And then we can just plug in the information that we have. So they gave us m as 5, and they gave us the ordered pair x1, y1 as 2, 3. So we're just going to plug that information in. We have y minus our y1, which is 3. Our m is 5. Then we have x minus 2. So we have this in point slope, but we need to have it in slope-intercept form. So we're going to treat it just the same as we did before. We can't do anything with that minus 3 yet because the parenthesis is not gone. So 5 times x is 5x. 5 times negative 2 is negative 10. Solve for y, we have plus 3 on both sides. So then we're going to have 5x minus 7. So then we now have it in slope-intercept form. And that's what we wanted. Sometimes I'm going to tell you to stop and do just point-slope form. So you really want to make sure that you're following directions. So here it just says slope-intercept. So that's why we had to distribute. Now we're going to graph the best that we can. So I had to go a little bit further down because we have a negative 7. So we have 5x minus 7. So 1, 2, 3, 4, 5, 6, 7 down. But then notice that our slope is 5 over 1. So that means we're going to go up 5, right 1. So we're going to go 1, 2, 3, 4, 5 spaces up. 1 to the right. So 1, 2, 3, 4, 5, 1 to the right. And you can keep that pattern going. And then you're going to draw your line all the way through the graph and having arrows on both ends. So you can check to make sure that you did this correctly by, all right, the slope is 5 over 1. Go back to the problem. That's what we wanted. And then it says it contains the ordered pair 2, 3. On our graph, does the line have 2, 3? It does. So since it satisfies both parts, we know that we did the graph right. All right, if you could hit pause and then try this on your own. So we're going to start with point slope form. We have m equals negative 2. And then we have x1, y1, which is 3, 1. So then we're going to do the y minus our 1 equals negative 2 parentheses x minus 3. So then we have y minus 1. We can't do anything with that minus 1 until we distribute. So negative 2 times x gets you negative 2x. Negative 2 times negative 3 gets you a positive 6. Now that we've simplified the parentheses, we're allowed to add 1 on both sides. So then we have negative 2x plus 7. So we have it in slope-intercept form, and then it's easily graphable. So we have evenly distributed tally marks, the best that you can. Now in this case, we're doing m is negative 2 over 1, and then our b value is 7. So we're going to begin at positive 7. And our slope is telling us to go down to right 1. Down to right 1. And we're going to continue that pattern as many times as you need to. Make sure your line is straight. And then we have a slope of negative 2, which is correct. But then I can see 3, 1 is actually an ordered pair on my graph. So I know that I did this correctly as well. Now, one thing that I do want to mention, if I give you a problem that says write an equation in slope-intercept form, and I give you an m of, let's say, negative 1, and then I give you an ordered pair that's -3, 2. Okay? You have to be careful when you plug in the information. What I mean by that is that if there's a negative involved, you want to make sure that you're using parentheses when you substitute in. So we still have to use the point slope form. But then it's going to be y minus 2. You don't have to use parentheses for that because it's a positive 2. So y minus 2 is just minus 2. The part that I worry about, students do this. So x minus comes from the problem. But then look what our x1 is. Our x1 is -3. You still have to put that -3 in. You can't just leave out the negative because there's already a minus. So this is where I want you to use parentheses. That minus sign comes from the form. That negative sign comes from the problem. So just be careful when you're simplifying, because negative and a negative make a +3. So those two minus signs really make it an adding 3. And then you can distribute like you've always done. And then you can do it in slope form, slope-intercept form. I'm not going to graph that. I just wanted to show you if you ever get a negative x value or a negative y value, you have to be careful because the minus comes from the form, the negative comes from the problem. So you're going to have to do the minus and negative part.